As organizations move from people ready data to AI ready data, metadata becomes the difference between information that's stored and intelligence that actually works. To unpack how metadata unlocks trust, scale, and speed, and why the future of business depends on getting it right.
The future is here already. It's just not evenly distributed. Yet. Today's world teems with innovation. The nexus of hardware, software, and human ingenuity promises a revolution in possibilities. What does tomorrow look like? Witness Future Proof.
A visionary is one who can find his way by moonlight and see the dawn before the rest of the world. And I thought to myself, that's really what visionaries are in our industry. And I had a fun story to share. Almost 25 years ago, about 24 years ago, I became self-employed again, and I picked up a company called QualiWare, really nice guy, Steve Arbogast, and I was talking to him about their technology, and he said that he was talking about his metadata layer. I said, I talk to a lot of vendors, and they all talk about their metadata layer. Wouldn't it be great to have a standardized metadata layer? That way, people can interchange data across platforms and different applications, and it would just really facilitate integration. And he goes, oh, yeah, that is a pretty interesting idea. What are we talking about today? Open Metadata, a project for a standardized metadata layer that allows you to integrate all your different applications. So you don't have one set of metadata for your ERP, one set for your data warehouse, one set for your CRM. No, it's the same. It brings that all together. And I'm so excited. I feel like a dream has come true here today as we hear from Mark Madsen and the folks at Collate about the Open Metadata project. So with that, Mark Madsen, take it away.
Hey, thanks, Eric. Um, yeah, so I thought just a few brief opening remarks to kind of set the stage for what we're talking about, little of where we are. Because I feel like not everybody really understands what we mean when we talk about things like metadata. And one of the problems with data describing other data and where it comes from and how it's used and so on is the systems that it comes from. And everybody just assumes data appears magically and there's this big pool of applications and stuff just happens. But there are different kinds of systems in an IT organization. There's the financial systems, the transaction processing systems, the stuff everybody likes to complain about. Then there's all the analytics systems, the BI, the data warehouses, and so on. And they have a different architecture because they're built for a different purpose. And so they use different technologies, different databases, different methods of creating or modeling the data. And so what you find is transaction systems are great at technical metadata because it has to be reliable, it has to be robust, it has to be good enough to do the work that it's supposed to do. But that's all done in the application. And so you don't need glossaries and definitions and other things, descriptive metadata that you need in analytics because you're just doing transactions and it's all in a form. But in analytics, you're interpreting things. You're trying to figure out which of these three fields is the actual revenue field I want when they're all labeled revenue. And so you start to get into these definitions and glossaries and so on. And then we added, later we added all these collaboration systems, whether it was, things like Slack or applications like Teams or just, boring stuff we've had forever like email. All of those systems have virtually no data model in them that you can peek into. We're trying to use these systems as data, especially for AI. The metadata, if you're talking about images and audio and so on, often is embedded inside the file itself as a media file that you have to somehow magically strip out if you're lucky, and it's highly impoverished. And then you throw in things like all the logs that go with these systems so that you can keep them up and running, and its data is trapped and dispersed. And so what you mainly have is where did it come from and where's it going to? And then we have this stuff that, if you're in something like manufacturing or oil and gas, you would call OT instead of IT, right? Because it's operational tech and it's in a different domain. And I would categorize, the .com kind of infrastructure, if you're a streaming company like Spotify, all those things, they just produce logs. And they do have data repositories, which may or may not be databases. And it's very different from the standard data stacks. And all of these have different kinds of metadata, or in that case, usually no metadata at all. And so you don't know anything about these. And so that's where the data comes from. And then you're trying to mash all that stuff together. Can you advance that, Eric? Sorry, I forgot I don't have a key to push. And normal in most organizations is we had all these sources and we slapped all these analytic systems out there, and we've got warehouses and marts and self-service repositories and just self-service direct connected things. And it's a mess, but it's what everybody's got. Can you move that, Eric?
Hmm.
And so, one of the things in the big data market, so we'll go back 10 to 15 years, was, hey, we're going to make a thing, we're going to dump all this stuff in there. And the answer is get a catalog, right? Get a data catalog and just slap all the metadata for everything. But as I just said, there's different kinds of good metadata from different systems that describe different things. Half of it's locked in people's heads. And then there's systems that don't have it in the way you expect. And what does the catalog end up doing? It just shows you where everything is. That's it. It's, hey, great, we can see the mess. But what does this solve? It only solves visibility. Push that, please. Um, and from my perspective, the new world of metadata, as we would look at it, is that some of it's for managing data, which is why we had metadata and analytic repositories. Some of it is for finding data. As you go into the self-service environments and world, it's where is the stuff that I want or need, whether that's self-service in the form of a data scientist or self-service as an end user saying, I need some specific information. And then, the third part is in the automation frameworks. And that's both very old, ETL from, 25 years ago, buried inside those tools, to the very new automation where we're talking about building pipelines and pushing things into production and monitoring the deployments and keeping track of what and why. And all of that automational information that's required. And so all of these activities, whether you're data management analytics people or users and scientists or developers and DevOps people, is you need metadata. Can you advance that, please? So what we see then in the tools market has been this 25-year mass disaggregation from monolithic ETL tools and BI tools and environments to the so-called modern data stack, which itself is fragmented everything, right? So an ETL tool is now the data pipeline pieces for programming, plus the provisioning, the scheduler is separate, the monitoring is separate. There is no metadata. If you look at something like dbt, where is the metadata? You end up having to have third-party pieces, and then you're assembling this. And so the modern data stack has broken apart everything to the point that now we have the modern data stack of data stacks, as Lauren Balick calls it, which is even more important now to have some sort of hub of metadata for all the different things going on because it's all fragmented into even smaller and more fine-grained pieces. Can you push that slider? Uh, and if we think about this historically, what we had was an evolution where we didn't have any for a long time because we didn't care, to analytic environments where it was really for the purpose of interchange. I want the metadata of my ETL tool or my database to be visible in my BI tool. And as things change in one place, I want them to appear in the other place. And they were really focused. We got repositories that extracted everything, dumped it in a repo, and were focused on interchange. Get blobs of metadata from point A to point B and relate these systems. And then as the big data and the data science and the self-service era started to come out and everybody had analytic systems, it was all about inventories. And so the focus on the user shifted from these technical people doing backroom stuff to users trying to find data in analytic repositories. And so the catalog appeared rather than the repository. And the catalog was all about helping users find stuff and emphasize glossaries and self-service and findability. And so it was really, focused on a different class of user. And And now we're at this point where we have been evolving things for, I want to say, the last 5, 6 years, which is really a new emphasis more on the people doing development, building pipelines, as well as the self-service people. And the real focus there ends up being automation, managing things as they move from A to B and the activities and so on. The reality of our environments, though, is that we have all of these things, and we need to be paying attention to all of these. But because we're talking largely about product market here, product vendors want to focus on making money as quickly as they can based on whatever the dominant domain is. And so they're trading off one side versus another, one group of users versus another. And the problem there is that you're giving up gains that you had from before while you do new things to fill the gaps of what you didn't have. And metadata standards are a big piece of what should have, but never quite evolved in these markets. So the metadata focus, the user focus, the systems focus evolved over periods of time. And now we're talking about pipes and tool chains. And instead of being in the data center, but distributed over a bunch of piles of repos, we've got cloud and we've got many more analytic repos, but we've also got these problems of how do I get stuff to where it's needed? The problem becomes provisioning as much as make good analytic data. Can you advance that, Eric?
Hmm.
And when we talk about what kind of metadata, as we went through those eras, it was different classes. And metadata standards are extraordinarily difficult because it's hard to describe what we mean by all this metadata. And there aren't really good taxonomies or ways of describing it. I tend to use a bucket of three, which is business metadata, technical metadata, and operational metadata, which almost aligns to these three eras about business metadata is just what is this stuff and who owns it and where did it come from and what's the definition of it. But along with that is the curation of that now that we have many analytic repositories instead of just one. And that's a blind spot, and that's a part of this, operational or active metadata. There's technical metadata, which is just all the stuff of data types and schemas and tables. And on the operational side, it's who's using what. How often is this stuff accessed? How is it processed? And then how is it used? Right? These things are black holes for most of the data catalog industry or the data repository industry, or the things SAP would give you. And so there's this sort of unmet need on that side. Can you advance that, Eric?
Hmm.
But when we go back to the basics of what do people want today in metadata, and especially as we focus on things like data management, um, it's still the two basics. How do I find data? That is the self-service bits of where is stuff. And then how do I support data governance and management? How do I make sure that policies are being complied when I don't have one policy lockdown prison of the data warehouse, but I've got 15 analytic repositories? And I feel like this is a good departure point to, hand this over to talk a little bit about what Collate's doing and about uh, metadata in general and about this new world of metadata that we're going into.
So today we'll talk a little bit about what Collate is doing to solve the problems that Mark was talking about. So Collate is building semantic intelligence platform, right? So especially for trusted data to make your data AI ready. Just a quick background on Harsha and me. We've been working on big data for a long time. At Yahoo, I was part of the core team that built Hadoop. And when Hadoop started getting traction beyond web companies, I was co-founder of Hortonworks. That's where Harsha and I started working together. Now, towards the end of Hortonworks' journey, we realized that there was, a scalable way of storing and computing data, right? But still, people were struggling to find business outcomes with all these, fantastic platforms that were available. We wanted to understand the user side of the story and why data is a struggle, and so joined Uber. Right? Uber is a world-class data company, but when we joined Uber and saw from inside, data was still a mess, right? Basic APIs were broken, there was constant firefighting and things like that. And Harsha and I led a program to actually take Uber's data to the next level That's where we realized, Mark, that some of the metadata problems that you're talking about, metadata is foundational to solving many of these problems, right? And after having solved these problems at Uber to a certain extent, we realized that this is a problem that everybody is facing, and that's when we started open metadata and a company Collate around open metadata. So that's our founding story. Now, what are we doing in Collect, right? So when we started Collect, Gen AI and ChatGPT was still not there, but its AI is coming in a big way, right? To data, and first few years we were building this unified metadata graph to provide context for people to understand the data end to end, right? And it includes, Mark, all the different systems that you're talking about, right? The OLTP, OLAP, your other collaboration interfaces, right? Tracking all of this metadata, right? And build a context, end to end context for people. What we realized is as AI started coming in, we realized that context is not just enough, right? You need meaning, right? Meaning that is precise, right? That you
Hmm.
can infer and reason about. And so context plus semantics has come in a big way, going from people ready data to AI ready data, right? That's the transition that we are powering. Now, what does this context and semantics enable, right? Now, first of all, to enable context and semantics, so far you see a lot of work is manual, mundane. So we are using AI to get the data AI ready, right? It's humanly not possible to document, add semantics and all of that. So we have built agentic framework to organize your data, manage your data, and build trust in your data so that it becomes AI ready, right? Now, with that context plus semantics, we are building conversational interfaces, right, where you can actually, business users can make use of the data. You're no longer worried about the structure and the technical metadata. You're elevating how you consume and understand the data to the business user level through conversational interfaces, right? Now, what is semantic intelligence, right? Now, metadata that we were initially focused on, we've, through the power of open source project Open Metadata, we have built 120 plus connectors, right? Connecting all the way from OLTP, your ETL pipeline, your orchestration tools, data warehouses, lakes, right? Your dashboarding systems, machine learning, all of this metadata is collected and connected in a unified metadata graph, right? On top of it, what we are adding is a semantic layer. This is where your business context comes in with shared definitions, right? And the shared relationship and the shared context, right? This is what drives shared meaning for the data for both people and AI, right? So that's what semantic intelligence is, bringing not only context, but meaning to the data, right? Now, with that, what we have built in the open source project is a unified experience where you can discover the data, understand the lineage and the impact analysis. We have native data quality, right? Automated data quality to ensure that the data that you are using, both, from people and AI, is high quality and trustable, observability to understand the operational aspects, and then finally governance, right, to make sure that the data is being used in a compliant manner. This unified experience, the workflows that it enables for people is also used by Collate AI, right? And as I was talking about, we have conversational interfaces to make data accessible, data management accessible for people through natural language. And then we have agentic framework that automates a lot of work that is done today, right? The quality, observability, governance, right? And other data management things through agentic. In fact, you can build your own agentic workflows with our AI studio. And then finally, we have built MCP that that provides both the context and the semantics that we have enabled through different AI tools so that you can use your AI tools to work with your data, right? And this is how we are bringing all the different data practitioners together, right, with the semantic and the context to collaborate together. And we believe collaboration is a big missing piece. That's what we are trying to address with our platform. Now, all of this is built on the open source project called Open Metadata, when we started Collate, we decided that the, the metadata is an important, problem to solve, and needs to be solved through open source and open standards because it needs to be interoperable, right? There should not be any vendor lock-in, and that's why we started open metadata project from the ground up 4 years ago instead of open sourcing from, maybe Uber or previous companies that we work with. So we started from the ground up. We have invested a lot of time and effort in the community, and this is one of the fastest growing communities, and it's the number one project in related to metadata, with 12,000 plus community members, 3,000 plus enterprise deployments, and all the other 4,000 400 plus contributors, with all the project community health metrics doing really well with in terms of stars and forks and downloads and all of that. So open metadata is what is powering what we are building in Collate, especially the AI layer, right? Giving us a way to build semantics and context. Now for I've talked enough about it. We'll give you a glimpse of what this looks like, and over to you, Harsha.
All right. Thanks, Suresh. This is our metadata platform, Collate. We built it. So when I log in as a user, I get to see all my metadata organized really nicely for me, and all the things that I care about. What are my owned data? What are my top tier data assets, domains, and everything else. But before we get there, how do we get the metadata from your systems? As Mark pointed out, the metadata and the data systems is really complex today. So to do that as an admin, I can get into my settings and services. And as you can see, we have covered all the way from APIs to your ML models, your databases, your pipelines, everything you can think of as an object in a data world, it is codified here. So to bring in a metadata, all I need to do go here is and add a new service. And you can see various different databases, data warehouses, connectors that we pre-built is available to you. For a simple click, I can just select Snowflake and give it a meaningful name and fill in all the details that requires me to connect to Snowflake. And that's pretty much as an admin I need to do, test the connection to make sure it works and click next. Once you have done that, what we have to, there's an existing service, I'll go in there, is to deploy what we call as metadata agents and Collate AI agents. One of the challenges of bringing the metadata, right? So you have your technical metadata that we can bring in your tables, your store closures, your lineage, profiler, auto classifications, and usage. But while we are doing so, how can we help the users get the best out of the metadata platform? Like how can we enrich the metadata that we are getting through our documentation agent? Again, traditional catalogs, you have to go manually document all of that. So how can we enable documentation as the metadata is coming in? Similarly, since we are profiling the data itself, we can use our profiler agent, our data quality agent, to add data quality test on the fly. And finally, tiering agent, how do you recognize the most important data within your organization? So all of this automated by just click of a button. Once the data appears here, the metadata, you can see all the insights about the data. So in the Snowflake service, what is the description coverage that I have? What is the PII? What is the tier? What is the ownership? And you can see what is Collate AI doing right here, how many descriptions it's able to generate, how many tags it's able to suggest and add to it, how many data quality tests it's showing up. So this gives really insights into how your data is actually operating right now from, let's say, a 30,000 foot level, right? So you get PI distribution, your most used data assets, including the most expensive queries. So now all of your metadata is organized. Now your users are coming into this platform and they want to kind of figure out what the data is about. They can kind of come here and search for a table. I'm following this particular table and understand what is the schema that exists. What are the tags being assigned? What is the queries? What is the data observability, including lineage, all the way from column level lineage? These are all great now, but I'm a data analyst. I've been told to find, we are running eco-friendly products in our store and want to find out how they are doing compared to non-eco-friendly products. Now, that's a task that I've been assigned with. In a traditional sense, you have to go to your catalog, figure out all your tables. And if you're lucky, you find the owner, understand them, talk to them, then go on to kind of figure out queries, how to query it, run it, all that full gamut of things, finally to create a dashboard. With Collate, we built Ask Collate. So here I can just come here. Now it's powered by metadata, not just metadata, but the semantic meanings of that metadata. I can just ask, do we have eco-friendly products? So when you're asking this question, the LLMs here are powered by the entire semantic graph that we built underneath it. It knows what is eco-friendly product means. It knows where the customer data means. So it will be able to find different type of customers data tables here. And that's the reality of today's situations. You have sprawling data, you have copied data, you have different model data. But it's able to recommend you the exact table that you should be interested in. In this case, it's able to find out the most relevant data asset is customer 360, and it's based on the schema and the meaning of this particular data inside in this table. Now, this is great. Now I want to know, show me more details about customer 360. I want to understand what exactly is customer 360, what is the schema, are there any data quality issues running in, are there any outstanding queries that I actually can look at and make my further analysis based on. So as soon as I ask the question, we are not just throwing the wall of text, we are actually giving it interactable widgets of what this particular table is doing. I can see all the schema, columns and everything else, including the data quality. There are around 12 tests, 11 of them are passing, which is great. And I can see what it's failing, if it's related to my issue or not, including the queries that are running against maybe my colleagues are running. Are there any scheduled queries that are running so that I can learn how my colleagues are working with this particular table? And lineage, how is this data getting prepared? So this gives me a lot of context and a lot of understanding of this particular table. Now, from here on one, I want to kind of get to the next level of question that I'm actually here for, which is, can we generate eco-friendly products versus the rest? I want to generate revenue of eco-friendly products versus rest. So not only we discovered the table, we understood the context of where it's being used, how it's being used. Now I'm trying to get to the final answer, which is I started with, where my task is actually find the revenue of the eco-friendly products versus rest. So given the context that it has, given the queries it has, and how they are being used, now it's able to generate me a query that is exactly can be used against Snowflake. And it's not only using that, and it's running against my Snowflake tables.
While it's doing that, I have a quick question for you. LLMs, of course, receive a string of text, which they convert to vectors, and they receive back a string, well, of text that was generated by vectors. How does the graph structure actually get pushed into the LLM, or is that through MCP? How does that actually happen?
Yeah, so what we are doing underneath is not only we do two things. One is obvious, it's the vectorization of this data that we have. And we also have a semantic graph, which is how is this particular table related to which term? Could be a glossary, could be an ontology itself. What is an eco-friendly product means in this company? What is a revenue means in this particular company? All of those definitions are encoded and how they are related. So when an LLM is asking, when I'm coming and asking these questions, it's able to find out with the hybrid search the vectorization of the data and as well as the relations it belongs to.